Afghanistan is carving a new river into the desert, a 285-kilometer lifeline meant to turn dust into wheat and rewrite who controls water in Central Asia. It's not a concept. Excavators are biting through the steppe right now. But every liter pulled from the Darya ripples downstream, from border farms to a shrinking sea. This could feed a nation or ignite a regional fight. North of Balkh, bulldozers slice a straight scar across Afghanistan's steppe, channeling the Darya toward fields that haven't seen dependable water in decades. This is the Qosh Tepa Canal, a national gamble to swap wheat imports for homegrown harvests and to anchor rural jobs after years of war. The logic is simple. Capture seasonal flow when the river runs high, spread it across new command areas, and build storage and gates to ration the dry months. But the timing isn't accidental. With food prices volatile and neighbors expanding their own intakes, Kabul wants control over water to equal sovereignty over crops. The question isn't whether the canal matters, it's whether engineering and diplomacy can keep pace with ambition. The Qosh Tepa Canal begins on the Afghan bank of the Darya in Kaldar, Balkh, then cuts southwest across Jaljan toward Ankoy, Faryab, a straight engineered trench meant to move river water onto land that's been rain-starved for decades. The main line is planned at about 285 kilometers, with intake works near the river, control gates along the trunk, and branch canals to fan water into command areas. Hard numbers. Public designs and feasibility material describe a channel roughly 80 to 100 meters wide and approximately 8.5 meters deep, sized to pass large seasonal flows. The agricultural ambition sits in the same league. Greater than 500,000 hectares brought under irrigation if distribution works, soil prep, and on-farm systems are delivered. Several analyses frame the intended diversion at approximately 20 to 30% of Darya flow, a figure that changes by season and is hotly debated by downstream states. Engineering and logistics. The intake structure and primary earthworks are the critical path. Stabilize the riverbank, armor the headworks, and keep gradients steady enough to avoid dead pools or runaway erosion. Feasibility notes and regional briefs list 3 phases for the trunk plus branch canals, approximately 37 kilometers and approximately 45 kilometers. Satellite timelines show rapid excavation since 2022, with Phase 1 declared complete in late 2023 and Phase 2 reported as largely finished through late 2024. Money and timeline. Officials cast the project as a national priority with state-led funding. External reporting points to an aggressive build sequence aiming for early water deliveries before full distribution. Build-out is complete. Specific CAPEX bands vary by source and are often undisclosed. What's consistent is the schedule pressure to reach initial irrigation blocks while civil works continue further downstream. Reality check. A canal this wide and shallow in low S and sand risk bank, slumping seepage and siltation unless lining, reap wrap, and gate calibration are executed and maintained. Any headworks missteps could strand flows or overcut banks. Downstream, every cubic meter captured upstream can tighten allocations for Uzbekistan and Turkmenistan, sharpening diplomacy around basin governance. At the basin scale, the Darya typically carries on the order of approximately 75 cubic kilometers per year, with wide swings by season and year. Any new sustained diversion, therefore, has consequences that cascade far beyond canal banks. A long-standing regional norm, the 1992 Almaty Agreement Framework, administered via the Interstate Water Commission, aims to preserve existing allocations and minimum sanitary flows to stabilize the delta ecosystems. Technical assessments have recommended approximately 8 cubic kilometers in high water years, approximately 4.6 cubic kilometers in average years, and greater than or equal to 3.1 cubic kilometers in low water years for the lower Darya wetlands and Aralsi interface. For Qosh Tepa, credible estimates for intended withdrawals generally cluster in a approximately 20 to 30% share of Darya flow, though figures vary with season, hydrologic year, and political messaging. Reporting and expert briefs through 2024 to 2025 frequently cite this ban when discussing potential basin impacts. It is also the range most often referenced by downstream officials and analysts debating risks to Uzbekistan and Turkmenistan. Treat any point estimate with caution. Design capacity, seasonal operations, and enforcement at the headworks will ultimately govern the real take. Downstream stance. Uzbekistan has publicly signaled concern, and open talks focused on how much, when, and under what rules Afghanistan can abstract, seeking predictability during critical irrigation windows, spring/summer and drought years. These diplomatic tracks have been on and off since late 2023 and run in parallel with domestic efficiency pushes inside Uzbekistan to brace for tighter supplies. Aral Sea Lens. Environmental voices warn that any sizable permanent reduction in the Darya will further strain the Aral Basin, compounding evaporative losses and salinization trends, especially in low-flow years when sanitary flow targets are hardest to meet. While some forecasts are pessimistic by design to provoke coordination, the direction of risk is clear. Larger upstream abstractions raise the bar for downstream conservation, infrastructure upgrades, and cross-border scheduling. Bottom line, hydrology isn't just a number, it's a calendar. The same annual volume diverted in May to July bites far harder than in October to December, which is why negotiated seasonal caps and drought year rules matter as much as nameplate canal capacity. Irrigation is only half the story. The point is crops. Qosh Tepa's planners frame the canal as a food security lever, shifting from volatile wheat imports toward stable domestic harvests. The first command areas are slated for wheat and barley, cool season staples that match spring flows, with cotton and oil seeds in warmer districts, plus fruit/vegetable belts near market towns where short haul times keep quality high. The agronomy logic is textbook. Match water windows to crop calendars. Keep rotations tight to protect soils, and avoid water-hungry choices in drought years. On-farm efficiency. To turn canal water into grain, fields need more than headworks. Land leveling, farm turnouts, and measured delivery, rotational scheduling or measured quotas. Lined laterals and gated pipes curb seepage. Laser leveling and surge irrigation raise distribution uniformity. Even basic upgrades can lift water use efficiency, WUE, dramatically compared to ungraded flood irrigation, which is critical when neighbors watch every cubic meter. Post-harvest in markets. New grain without storage is just cheap grain once. The economic upside depends on silos, dryers, and rural roads that move harvest before spoilage sets in. Milling and oil press capacity then decides whether value stays in country. A simple rule of thumb: every step kept inside Afghanistan, drying, milling, ginning, packaging, multiplies rural incomes and cushions state finances against import price spikes. Jobs and rural stability. Canal agriculture is labor-intensive at launch: earthworks, land prep, canal maintenance, and seasonal harvests before mechanization ramps. That early surge can anchor households that might otherwise migrate, provided inputs, seed, fertilizer, diesel, and credit are accessible and predictable. Risks to watch. Without drainage, command areas can waterlog and salinize within seasons. Without fair water turns, upstream farms hoard and downstream fields starve. Cotton can chase quick cash, but degrades soils if rotations and residue management aren't enforced. Black market pumping from the trunk or laterals can unravel allocations unless metering and enforcement are real. Bottom line, the canal can grow wheat. The system, on-farm efficiency, storage, processing, and rules, decides whether it grows wealth. Rivers don't respect borders. Canals must. Every cubic meter Afghanistan captures changes the hydrograph that reaches Uzbekistan and Turkmenistan, and, by extension, the stressed Aral Sea system. The environmental stakes are twofold. 1. Ecological flows to sustain delta wetlands and curb salinity blowups, and 2. On-farm drainage to prevent waterlogging and salt creep inside Afghanistan's own command areas. Without collector drains and outfalls, fields will yield for a few seasons, then crash. For neighbors, predictability matters more than perfection. The fastest path to lower tensions is a rules-of-the-road package built around seasonal caps, higher abstraction tolerance in shoulder months, tighter in peak irrigation, drought year rules with conservative triggers, snowpack, reservoir levels, upstream gauge thresholds, sanitary flow floors to the delta, explicit cubic kilometer targets by water year type, telemetry and transparency, live headworks data, public weekly releases, and joint audits. Joint scheduling across canals and reservoirs so pulse diversions don't collide with downstream planting windows. On Afghanistan's side, environmental diligence looks like graded command areas, subsurface drains where soils demand it, selective canal lining at high-loss reaches, riprap at bends to stop bank slumps, and desilting basins to keep sediment from smothering laterals. On the transboundary side, confidence rises when parties publish hydromet data, share seasonal forecasts, and allow third-party verification, e.g., satellite-based evapotranspiration checks during the first critical years of operation. Diplomacy will track engineering. If the headworks runs to plan with measured withdrawals and transparent reporting, basin politics trend cooperative. If flows spike during neighbors' peak demand, or delta salinity flares, hard bargaining resumes. The canal can be framed as a regional food security stabilizer if it comes with verifiable guardrails. Without them, it will be read as a unilateral grab with familiar Errol-era echoes. Bridge. Governance is policy on paper. Operations are policy in practice, which brings us to progress, money, and the long list of technical risks. Where things stand. Earthworks have advanced in stage segments along the trunk, with visible stretches cut through loess and sand and interim access roads paralleling the canal. Public statements have described a multi-phase build, trunk first, lateral second, with early water delivery to pilot blocks before the full distribution web is finished. That sequencing buys political goodwill, greenfields fast, but pushes a lot of engineering and O&M debt into the next seasons. Funding picture. The canal is framed as a state-led national priority, with a mix of public works mobilization and line-item budgets, rather than conventional project finance. That makes transparency and cost discipline harder to track, but can speed decisions on procurement and scope changes. The practical constraint is recurring cash flow for O&M, desilting, bank repairs, gate maintenance, telemetry, and enforcement. A canal can be built once. It must be paid for every year to keep working. Critical risks to manage. Hydraulic grade and controls. A shallow gradient over long runs means any surveying error or subsidence can stall sections or cause overtopping. Calibrated gates and weirs at intervals reduce chaos. Seepage instability. Unlined reaches in sandy or collapsible soils risk lateral losses in bank slumps. Selective lining, toe protection, and riprap at bends are the minimum. Sediment and desilting. The Darya carries load. Without settling basins and routine dredging at the headworks, laterals will choke and deliveries will skew upstream. Erosion and flood pulses. High flow events can undercut banks at the intake. Revetments and emergency drawdown protocols keep the structure safe. Operations and fairness. If rotations aren't published and enforced, upstream users will hoard and downstream users will be starved, breeding black market pumping and conflict. Data and trust, gauges, telemetry, and public weekly reports are not luxuries, they are governance. They also anchor any cross-border confidence building. What to watch next? Proof points include a dated commissioning of the headworks under controlled flows, the first metered rotations to downstream laterals, publication of a seasonal abstraction plan, normal versus drought, and a funded O&M line for year one. If Qosh Tepa works as engineered and governed, it reshapes Afghanistan's food security math first, then Central Asia's water diplomacy. On the upside, a stable spring diversion matched to crop calendars could displace a meaningful share of wheat imports, anchor rural jobs, and spin up local value chains. Dryers, mills, oil presses that keep cash inside the country. In a best-case scenario, measured abstractions in shoulder months, transparent telemetry at the headworks, and enforceable rotations downstream would calm neighbors and prove that upstream development and basin stability can coexist. Flip the switches the other way, and the same canal becomes a stress multiplier. Over-abstraction during peak downstream demand, opaque operations, or a year or two of heavy siltation that throttles laterals would erode trust at home and abroad. Environmental pressure would surface fastest in the lower Darya, where ecological flow targets already strain in dry years, amplifying salinity and wetland losses. Inside Afghanistan, thin O and M budgets would show up as bank slumps, clogged offtakes, and widening inequality between upstream and tail-end farms. For global viewers, one analogy helps. Think in percent of a major river's annual flow, not just kilometers of canal. Even a mid-single-digit share of a basin-scale river, if taken at the wrong time of year, can have outsized impacts on planting windows and delta health. That's why the operational details, seasonal caps, drought rules, and public weekly reports matter as much as the bulldozers. Net-net, the canal is neither miracle nor menace by nature. It is a lever. Pull it with engineering discipline and transparent scheduling, and you get more grain with fewer fights. Pull it hard and blind, and you trade short-term harvests for long-term basin instability. The next 12 months, commissioning, first rotations, and the publication or not of a seasonal plan will tell which path Afghanistan and its neighbors are on. Here is what's real today. Excavation along the trunk has pushed through long, visible stretches across Balk and Yuzhin, with access roads flanking the cut and interim control points appearing at intervals. You can already see how the landscape changes when a graded channel intersects old farm tracks. New embankments, fresh borrow pits, and rough turnouts hinting at future laterals. None of that is theoretical. It's earth moved, banks shaped, and crews working. What matters next is time and sequence. 3 near-term milestones will tell you if Qosh Tepa is on a disciplined path or sliding into improvisation. First, a dated headworks commissioning under controlled flows, documented, measured, and stable, by the end of 2025. Second, publication of a seasonal abstraction plan for the 2026 irrigation year that sets caps by month and a tighter drought year schedule. Without that paper trail, promises are weather. Third, the first metered rotations to downstream laterals in spring 2026, with a public weekly report that shows where the water actually went. If those 3 appear, in that order, you will know operations, not just excavation, is taking the lead. For Afghans, the prize is sober but profound. Wheat that doesn't depend on a price spike halfway around the world, farm jobs that anchor households, and value that stays in country because grain is dried, milled, and moved on time. For neighbors, reassurance looks like telemetry. You can log sanitary flow floors that survive a dry year and a calendar that respects planting windows downstream. None of this is easy. All of it is possible.